after we have numbered our carbon chain, we number the chain in the direction that gives the lowest possible number to the branch. And so that's what I was talking about on the previous slide, numbering from either the left terminus or the right terminus in the way that carbon 1 is closest to a branch point. Oops. So we're numbering closest, carbon 1 is closest to a branch point. Okay, so if we look at our examples here, we can see that for the first molecule in the line of 3 molecules on the left, the longest carbon chain was 5 carbons. And then at carbon 2, we had a branch, which was a methyl group. And so carbon 1 is closest to the possible branch point. So we would call this 2-methyl, rather than numbering from the right to left, calling it 4-methyl. 4-methyl would be incorrect. For the molecule in the middle, we numbered from the right side rather than the left side. So we numbered right to left instead of left to right, because numbering from right to left gave a branch point at carbon 3, where numbering from left to right would have given us a branch point at carbon 4. So we want the lowest possible number for that branched carbon. And then in the last example, we have our 8 carbon chain, and there's a branch at carbon 4. If we had numbered from the other direction, the branch would have been at carbon 5. And 4 is less than 5, so 4 is correct. So for the example that I gave on the other side, when I numbered on the previous slide, I had said that let's number this from this 2 carbons instead of the 1 carbon branch point that we could choose, because that would give us a longer chain. And then that would goes up to maximum of 9 carbons once we determine which was the longest chain. And that had a carbon at branch 3 versus having a carbon at branched carbon 4. So we numbered in the direction from right to left because it gave us a branch at an earlier carbon number. And then from there, we could determine where our 2 branches were located. Oops. And that was at 3-methyl and 6-ethyl. So carbon 1 is closest to branch point. Now, listing our substituents in alphabetical order is the next rule that we're going to follow, so that we have, for their example, the longest carbon chain is 8 carbons. One, 2, 3, 4, 5, 6, 7, 8. And that those carbons, so I numbered from the right because this is 2 and this is 3, so 2 is less than 3, I number from the right. That gives us a branch at carbon 3, and at carbon 3 we have a methyl group, so 3-methyl. Then at carbon 5 I have an ethyl group, a 5-ethyl group, and then we have to compare methyl and ethyl and decide which comes alphabetically first. Well, ethyl does. So that when I write out the name, I'm going to put ethyl before methyl. So we have 5-ethyl-3-methyl octane as the molecule given in our example. Then the example that I have been using is the nonane, where we had a 3-methyl group and a 6-ethyl group. But ethyl comes alphabetically before methyl, so that when we write out the name, we use the name 6-ethyl-3-methyl nonane. There is one small thing that I can point out to you on determining if you have picked the lowest number correctly. And that is that if you add together the two numbers representing the branch point, for example, if we take this, if we take the example that they have given us here, one shortcut for being sure that you have the correct numbering is the following. Take your two numbers and add them together, and then take the alternate name and add the two numbers together. The other name that you are considering. Whichever has the lowest sum is the correct numbering, so that the correct numbering is 8 rather than 10. So that we have 5 plus 3 is equal to 8 is less than 4 plus 6 equal to 10. So 5 and 3 must be the correct numbers for labeling the molecule. Okay, we can have multiple substituents on a chain. We've been nice for the most part. We've been using one branch, two branches. We can have more than that. We can have up to as many branch points as we want, as long as we can identify the longest chain. So multiple substituents. For multiple substituents, if you have multiple substituents that are the same length for the branch. For example, I have two branches and each of them has one carbon. Then I can use a prefix such as di, tri, tetra to represent how many times that one carbon substituent appears. So in the first molecule at the top left, I have two one carbon groups, and so it's a dimethylhexane, but then I have to give a number indicating where each of the one carbon group is. So in this case, I have numbering from the left to numbering from the right to the left. We have 1, 2, 3, 4, 5, 6. We have a branch at a methyl at carbon 2 and a methyl at carbon 4. Instead of writing 2-methyl, 4-methyl, it's shorter to write 2, 4 dimethyl, and the 2 and the 4 tell you that you have a methyl each at 2 and 4. Then we have the example molecule to the left of that, to the right of that. And I should note that when you do have a dimethyl trimethyl group, you have a number for each methyl group, but you also are going to separate those numbers by commas, and you always separate a number from a letter by a dash. So numbering the molecule to the right of that, we have, I will number it from the right to the left. So this is a heptane, and I have a methyl group at carbon 2, a methyl group at carbon 4. Wait, did I? No, at carbon 5. See, 5. And an ethyl group at carbon 5. Ethyl comes alphabetically first, so it will be listed first in the name, and it is. We have 5-ethyl. And then we have our 2 methyl groups, one at 2 and one at 5. So we have 2, 5 dimethyl. And then we list our main chain, our heptane. Looking at the molecule below that, we have either 1, 2, 3, 4 or 1, 2, 3. So we're going to number from left to right in this case. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a decane. And we have ethyl group at two ethyl groups at 3. 3-ethyl, 3-ethyl. And then an ethyl group at 6-ethyl. And a methyl group at 7. And so putting ethyl alphabetically first, we have to state one number per ethyl. We have 3,3,6 triethyl, 7-methyl decane. Okay, so please notice our notes at the bottom. The chain is numbered in the direction that puts the lowest number in the name first. Yes, so from the side of the chain that gives us the first branch point first. And then the substituents are listed in alphabetical order according to the prefix that indicates the carbon number in the branch. So according to the methyl, ethyl, propyl, butyl, pentyl, etc. branch, they're listed in alphabetical order. Things that are not considered when alphabetizing are prefixes such as di, tri, tetra, and tert. So for example, T-butyl, we would be alphabetizing according to the B and ignoring the T.